Hey, and welcome to Hutsons-Hacks. Today I'm going to be taking you through my new package, the MLDataR package for Supervised Machine Learning datasets in R. So what we're going to do after this is we're going to launch our R Studio and get going with coding it. So what we'll need here is a couple of packages to bring in to work with. So we'll need the MLDataR package, dplyr, confusion tabler, and tidy models. These can be installed via your packages browser, so install and type the package. So if you want a confusion tabler, if you've not got it installed already, it's there. If you want the MLDataR package, that's there. Or you can just use it in command line, install packages, MLDataR. Let's just hit go on that. So it's already in use because I'm using it already. Let's just clear some of the stuff from the environment. That's another way to do it. So MLDataR, it's got a couple of data sets within it. We've got thyroid disease. We've got heart disease. And we've got diabetes as well. And I'm adding more of these all the time. So currently we're starting with 3 data sets. By the end of this year I hope to have 50 plus data sets in there. So I've already got another 10 that need documented and put into this package. So watch this space. But I thought it'd be a good idea to get the first version of the package up and running, so I've got something to work with. So if you just pull up MLDataR in the help file, so I've got the thyroid disease marked down here. So another way to do that would be to go diabetes data if I wanted help on that, and it brings up the diabetes data set and the documentation there. We're going to actually use, for this example, I'm going to create this as a DF data frame. This is going to be our thyroid data frame that we're going to be using. We're going to use the MLDataR package. We're going to do some modeling with it because that's the intention of it for machine learning. So I've got this thyroid disease data set, and if you look at the data frame, it's got quite a few fields. You've got this thyroid class, that's the thing we're going to try and predict. So sick, whether they've got thyroid disease or not, based on their age, their gender, if they've been on thyroxine, if they're sick, pregnant, if they've had previous thyroid surgery, if they've had different iodine therapies, etc., etc. So if you want to have a look at what this means, we can go to thyroid disease, and each of the columns will be documented around what it actually contains. So here we've got 3,772 rows and 28 variables. So we're going to want to do some splitting on that because we're going to do a machine learning project from this using tidy models. And things like the patient age, the gender, prescribed thyroxine. If you don't know what anything of these are about, we've got links to the hyperlinks to the specific areas where you can look up more information about it. Where you've got a gotcha, a swelling on your neck from a thyroid tumour, and the different types of readings that they give for thyroxine. So there's quite a lot of variables to it. We've got 28 variables to work within this data set, which is cool. So I'm going to go back to the my example data set here, and we're going to just start modeling it essentially. So let's create, first of all, I'll create a tidy models recipe. So the first thing we need to do though is set the class to make sure it's a factor. So we're going to set that as a factor, and we call this DF thyroid class. So that should set the factor. We can specify the structure as well, just to see what the structure of the data frame is, and that should have been converted to a factor. Right, okay, so we've got 2 factor levels, negative and sick, or not sick or sick, right? Okay, so you could do something more advanced than this, but I'm going to remove nulls from the data frame. So we get rid of all the null data essentially. So to do this, there's a couple of ways. You can do NA emit, but I'm going to use the complete cases function. So df, and I'll call this actually thyroid data. df, and I want to remove complete. So from the rows, because I'm using the row index, complete cases of the df, and then we're just going to have to specify that's a row. Okay, give me all the complete cases, and then I'm going to pipe through. This is why you need dplyr. I'm going to dplyr select. I'm going to get rid of the referral source as well. Okay, so if I run those lines, okay. Now, as you can see, this thyroid dataset now has been reduced down to 2,751 observations. So we've got less data to play with. You could do something like mean imputation, mice, median imputation, if it's something that you're really interested in. But for the sake of clarity and example, we're just going to remove these missing rows for now. Okay, so the next step that we need to do is we're going to then split and partition our data in machine learning land. So we're going to split our data. And we're going to do quite a naive split. So we're just going to do a training and test split. You could do K4 cross validation, or you could do a test training and validation split. So when I say train, test and validation split, what I mean by that is you have a training set which your model's trained on, and then to test the metrics of the model, you use your test set essentially, and it shows you how well the model fits to the test set from the training set. And then the validation set acts a bit like your production data set, whereby you've got that to finally validate the model once it's in deployment. Is one way of doing it. For now, you'll see a lot of examples where we just split a data simply by using a training and test split. Okay, so we're going to do the training and test split. So I'm going to set a random seed so your results are reproducible, so you get the same splits as I do. I always use 1, 2, 3, but that can literally be any number of your choosing. All sample. So we're going to use the initial split. I'm going to use our data set. I'm going to split by a proportion of, you could either put 0.75 or you could do a calculation. I'm going to do about 75% held out on my training, 25% on my test. Then I'll create another variable, which is going to be a data frame or a tibble. We use the all sample function from tidy models, and we use the training split. I'm going to use the split parameter, which indicates what our initial split is. So it says for the 75%, give it to the training, because we're using the training function. And then you'll have a testing function as well. All sample testing split. Okay. So what this will do now, if I run these lines, I've run those already. Run these lines, so I should get my training and test split. So you can see I've got 2,063 observations from that thyroid disease data set ready to go. Okay. So what we're going to do now is we're going to create our first recipe. Create a recipe. Okay. So what we need to do first of all is to create a variable. We're going to call it our thyroid disease data set. And we're going to add in a recipe. Okay. So we're going to use the thyroid class variable. And we use all the other observations from that data set. I'm going to use the data equals to our trained data, because we're going to train our model on our training data. Makes sense. We're going to step normalize. What this does is all the predictor variables, it does something called mean and max centering, or z-score scaling depending on what you set. But essentially it's a way to bring real outliers in your distribution closer to the mean, so the model can detect the true patterns more easily. Otherwise you'll find that the model gets massively influenced by outliers, which just tends to be what happens in statistical modelling. So we do some kind of normalization step at that point. And then we're going to do something called remove zero variance. So zero variance is if some of the independent variables don't have any variance within them, therefore we can't detect any difference between the y, the outcome, and the target. So therefore the actual variable itself is redundant, and it's not going to have any predictive power over the thing we're trying to predict. And in this case it's the thyroid classification label. So we get rid of zero variance. And if you need to link any of this, you can go straight to the Tidy Models website, and I'll give you a few links after this tutorial. So print. So print the TD recipe. So if I run all these lines now, I should have my splits. Alright, okay, I've obviously spelt something wrong. Let's see what it's called. So it doesn't like that. Let's just go to train data. I think I must have. Okay, let's pick that from there so we know where it's coming from, that data frame. Okay, I'm going to just run that. Okay, now I've got my recipe completed. So you can see the recipe outputs. It shows that we've got a recipe, outcome, which is thyroid class, and we've got 27 other predictors. And it says for all predictors we're doing some centering and scaling, and we're doing a zero variance filter on all our predictors. When we say predictors, they're everything else other than the outcome, or as what we used to call in traditional statistics, your independent variables versus your dependent variable. Okay, so what we're going to do now is we're going to create an out-of-the-box random forest model using parsnip. Okay, we're going to set this random forest model. We use a parsnip package. Use random forest. I'm not going to actually add any trees or any hyperparameters in on this one because it's not a tutorial on tidy models. It's more of a tutorial on how you can use my MLDataR package with a machine learning library. This even could be scikit-learn if you're using Python. You could import it into there. It can be Caret, it could be MLL3, it could be even Keras or TensorFlow or PyTorch, whatever your flavor is. Okay, so what I've done here is I've set my parsnip model object to random forest, set the engine, so there's an external package called Ranger, and we're trying to classify, so we are going to classify the thyroid classification label. Okay. What we're going to do now is create the model workflow. Okay, so we get that created. Okay, so we've got the RF, let's call it our thyroxine dataset workflow. So we set the workflow. We use workflows. You don't have to do the namespaces. I'll just make sure. I always do this, so there's no issues with R if it's got multiple namespaces of the same name. That can sometimes be an issue. You'll find that if you're a kind of an intermediate R user, dplyr sometimes overrides a lot of the default stats functionality in the package. So here, so I'm going to add my model. So this is creating the workflow steps. So say I wanted a new workflow, instantiate a new workflow. I want to add a model to that workflow, which is the previously defined random forest model here. And I'll add my recipe. So my recipe is called my TD, thyroid dataset recipe. So now I've got my workflow all done. I'm just going to run the line up before. Okay, got my workflow created. Perfect. If you want to print that out, you can see that I've got my random forest workflow, 2 pre-processing steps. You can do a lot more recipe steps than this. Is a very basic recipe. If you want to know how to do more with tidy models, I did a couple of tutorials on this. So look on my YouTube channel around creating a classification model from scratch in tidy models. It's a 2-parter, and then from there it shows you how to deploy your classification model into Docker, and how to create an API from that as well. That might be worth checking out. So now we're going to fit the workflow to our training data. Okay, let's set a seed again so we can get the same kind of results. Okay, so we've got this thyroid disease random forest fit object. Let's call it whatever you want to call it, whatever you want. TD workflow, we use a workflow we just created. We use a fit function, and data is going to be equal to our training data. Okay, so that's going to then instantiate the random forest model and get it spinning. Okay, so I've got that workflow, I've got that. Let's see the oh yeah, me and my spelling when I'm live coding, it's ridiculous. Okay, did I miss a step with? So let me run this line again, all of it. I'm getting some that aren't numeric issues. Okay, let me just check the structure of my data. If I've missed a pre-processing step here. Yeah, so everything else should be numeric. I've got double. See it drop that referral source? Ah, yeah, I know what's happened. Okay, so I need to actually assign it back to the TD because I'm selecting out that referral source. That'll work now. Apologies, guys. Live debugging as we go. So let me just run all those lines again. Okay. So what I was trying to do there, and what happened is I'd not made a change to this variable here, this TD variable. So I dropped the cases, but then I forgot to actually assign it to get rid of the referral source column, which is a nominal column. So it wouldn't fit the random forest model because all the data in it, in a machine learning model, needs to be numeric. Okay. So we've got this fit object sorted. And to extract the fitted data, I'm going to use something called extract_fit parsnip. So we've got our thyroid disease data fitted. I'm going to reference our previously created variable. I'm going to extract fit parsnip. So you should be able to see the fit. Okay, and if I just print that out, I can do it in here on the script line, or I can do it underneath on the console. Got this TF2 fitted. Gives you the outputs of my parsnip fitted object, sample size, number of trees that have grown by default, the number of random splits, the gene impurity index measure, and things like that. Okay, so now we've got our model fitted. We need to make predictions on it. We're going to then assess it. So I'm going to use the class predictions. So I'm going to create 2 new variables, class predictions. I'm going to use the base predict function, which is an S3 generic method, which all models in R override. So predict is something that's universal across all these different models. So we use the TD-RF fit, and we then use it against our test data. So what the model fit was against our test data. So you can see they've got these class predictions now, what it's predicted the test data to be. So we'll be able to evaluate how well our model performs, because we'll know the actual label with our testing data against its prediction. So we can do some validation statistics to work out how good is our model at fitting to our data, or if it's overfitting. And then in production, obviously you wouldn't have a classification label, you'd just have all these variables that you're then passing through into a live model to make a live prediction. And that's essentially how machine learning works. So strip this column out, that's your production data. To validate, you've got your testing data. And I go into this in greater depth in building a tidy models classification model from scratch, so please refer to that. So we've got our preds now. Oh, and actually, if you wanted to extract the prob predictions as well, prob preds, you'd predict our TD. We do the same exercise here. All we need to do is expose the type equals prob. Okay, so let's run that. So I've got my prob predictions now. That'll give you two variables. So it's the probability or the likelihood that someone's negative in terms of a probability score, and then you've got the likelihood that they're sick as well. That looks like it's got scientific notation on it as well. But yeah, it's predicting that the first observation is relatively high. Okay, and then I'm going to create a preds data frame where I'm going to bind all this data together. So we use the test data. I'm going to bind cols. We use class pred. I can use prob preds as well. Let's see if that works. So now we've got TD preds. So I should have so as I told you, the TD preds is just a copy of our test data with the new predictions. So now we've got our full data set that we can say what's the truth ground label, sick, what's the prediction label, pred class, and what are the probabilities, and we've got the probabilities there. So we've got that all good. We've made our predictions. I think we might need to convert these class labels into factors just to make sure they work with the function. So we've got TD preds, and we're just going to reference the pred class. I'm going to set that to a factor. Just do this just to make sure it's going to work with our confusion table function. Preds, and we've got the pred class. So it's just going to set it as a factor as we did before at the start. And we've got TD preds, and we've got thyroid class, and we'll set that as a factor. TD preds. Okay, perfect. So what we're going to do now is we're going to build a confusion matrix and do some assessment. So CM, and I'm using a confusion table package, which is an extension of Carrot's package, because it allows you not only to expose a confusion matrices, but it also allows you then to write those records out into a Excel file, a database file, whatever file type you like. So a TD preds is going to be the first input that we need. We need a thyroid class. I'm going to use that TD preds again. I'm going to use the pred class. I'm going to specify that are positive, so we know that out of the factors, if you look at the factors again, if I look at factors of TD preds and I look at thyroid class, Sorry, if I look at the structure is what I meant to do. Structure. Oh, it's one of those days. TD preds. You can see we've got the factor with two levels, negative and sick, right? So our positive is going to be our sick, because we're trying to predict whether they've got a thyroid disease. So in the confusion table function, you just need to set that positive to equal to sick as well. Okay, so if I run this line, confusion tabler is the package, and you need to make sure that it's loaded in the library. To get some help on this, you can just highlight it and hit F1. There you go. And it shows you how to use the function. Okay. And it says when it's finished, it's going to say building a record level confusion matrix to store in a data set. Build finish to expose record level CM, use the record level CM list item. So to get access to the objects now, what we're going to do is we're going to expose a confusion matrix first of all, just to assess expose confusion matrix. And we're going to CM confusion matrix. Oh, fantastic. So out of this classification, using just a out of the box random forest, we're getting really good accuracy already. So 97% overall. If you wanted to look at the balanced accuracy, it's about 96%. So the trade-off between our true positives and our true negatives. You can see that actually, in terms of misclassification of sick patients, it's only got 3 incorrect. And in terms of negative, it's only got 11 incorrect out of 629. I will note actually here that you probably need to do a bit of class rebalancing and check out my other tutorial on this, on building a classification model from scratch. I go into a function called SMOTE, which is synthetic minority oversampling, which deals with trying to rebalance an imbalanced class label. Because you can see with sick, we've only got a few observations of that. But actually with the random forest, it does pretty good at picking those out. That's why I chose the particular model. And a kappa agreement level, so how well this model will perform in the future, is pretty high. I'm pretty good with that. And it's better at predicting those that aren't sick of 98% confidence, but it's actually 93.4% confident at predicting those that are sick. So that's really very good. And then you can scale this out. So if I wanted to store those now, so store these, this is where the confusion table package comes in. Store the results as a flat row level. There's also a function in there called CM record level confusion matrix. So you can see now this has been put onto one line. So if we're going to create this as a data frame, let's just call this TD results. You'd see that I've got my thyroid dataset disease results. You can see it's one observation of 23 variables. So if I ran this again, and I wanted to keep creating and appending those on, I could just all bind onto it. So if I wanted to create another, so say that every day or every week you retrain this model. I'm going to all bind CM. This is just going to give me those same results twice, but it will give me 2 observations. I've got TD results. So every time it runs, it will give you a different timestamp every time, and it's going to give you that observation. You can just keep doing that going forward. And now I've got it set up is it exports it out into a database and just keeps pumping the records in, so I can monitor over time how well the model performs. And obviously because it's got the same structure, they're always going to be the same labels now. You'd have this as one data table in a database. So say now I want to store that. Let's F-write it. I need the data table package to do this. Library. Another one that you might want to install, data table. Okay, I'm going to F-write. I'm going to F-write my X, so my TD results The file is my model results.csv, right? It's going to write that out to my working directory, wherever this is. Okay. If I click that now, I can import it if I wanted to. I've got my model results that it's just outputted. Okay, so that's how you do it over time. And that's essentially how we'd build a tidy models model with my data set. Alongside this then, so where do we get this tutorial? This is all built into the vignette. So it goes through how you install the package, what data sets are included, the thyroid disease data set, and then we'll create this tidy models from my data set, so it shows you the steps I've just taken. So get modeling with the model workflow, links to the tidy models, lookup and reference. I put a lookup and reference around the recipes package, and then how you use the confusion table R function as well, the package, sorry, with its functions. Also included in here, and you could do the same example, is the diabetes data, diabetes class, so positive for diabetes, or you could use the heart disease prediction. Just show you an initial preparation step to get you going. So just convert the thing you're trying to predict into a factor. And with this one, I also use the confusion table R package with the dummy encoder function, because I've got multiple columns that I want to dummy encode. So I just specify them as strings and then run it through the confusion table R dummy encoder package. That encodes my data. And then from the originals, I'm going to get rid of the original items. And then I should have coded angina 1, 0. Okay, so like I've said, if you're happy with this, there's a data set that you're dying to be included in this package, please reach out to me at StatsGary. Just click that link on the vignette. That'll take you directly through to my Twitter page, or go to GitHub for package updates, where the MLDataR package is actually hosted at the moment. If you've got an issue, I've created an issue around loading new data sets as an enhancement. But if you've got an issue with the package, just hit new issue. So if you want to fork it into your own repository, you can hit the fork button. Star it, please star the package, please star the package. You can watch it, and you can even clone it down to your own repository just by taking that and then cloning it into your Git repo here. So clone it by copying that through the code function. Open with GitHub Desktop, which will do it for you, or you can download the zip, which has got everything around how the package is made and developed. So I'll just download a zip file for you. And yeah, as you can see, it's very new on CRAN, just as of today. And you can use it in your own projects at will, as long as you cite and source where you got it from. But other than that, that's great. That wraps it up. If you've got any comments, feedback, please let me know. Please subscribe to my YouTube channel. And yeah, thanks guys. I will catch you on the flip side. Thank you.